Are you a scaling SaaS founder?
Ready to make the leap from leading a team to leading an organization? Join us each week as we refill your think tank with actionable tips and strategies from great business minds you know and those you don't know yet. This is SaaS Fuel with your host, 5-time entrepreneur, SaaS founder, and globetrotting adventurer, Jeff Maines.
Welcome back to the SaaS Fuel podcast, where data is the compass that guides our ship, steering us through the seas of uncertainty to the shores of success. I'm your host, Jeff Maines. I help B2B SaaS founders like you grow from traction to scale. Here, growth is more than just numbers. It's about crafting a future-proof company, premium valuation, and leaders who build a business of significance while living epic, adventurous lives. 2024 is shaping up to be a year where the rule book gets rewritten. There is a seismic shift happening in the business landscape. Do you feel it? Yeah, it's going to be a strange year. A week ago Monday, we said goodbye to Q1 and we're barreling into Q2 now. It's almost tax time. And in some ways, growth has been slow through the first quarter. If you look at business overall, in other areas, it's expanding. Funds have tightened up, but possibilities are all around. It's really a weird market. I would say uncertain, and uncertainty creates opportunities. Think about 2020. Lots and lots of uncertainty. Some companies just tucked into their recession shell, and others blossomed. Zoom is a company that really capitalized on the entire remote work trend. The company name became a verb. They became the go-to video conferencing solution for businesses worldwide, and it happened so fast. They adapted to the changing landscape, which sent revenue skyrocketing. $623 million in 2020, which is pretty darn good to start with, to $4 billion in 2022. Think about that. 2 years. 623, 4 billion. Insane amount of growth. And I think we're at another point where there are similar opportunities. From many in-depth conversations I've had recently with business leaders, CEOs, market makers, and a few billionaires, I see 3 game-changing trends that are really set to redefine leadership and growth. The first one I'll call inclusive innovation. And I don't just mean like skin color, ethnic background, but it's much deeper than that. Gone are the days when innovation was confined to the C-suite or came up from R&D labs, something created in a vacuum. But in 2024, and I think beyond, successful companies will foster a culture where every single team member, regardless of their role, is encouraged to contribute ideas and to drive innovation. And the approach not only accelerates problem solving, which it certainly does, but it also boosts employee engagement and retention, which there is a deficit of in so many organizations right now. Employees are quiet quitting or not engaged or just jumping ship and moving on every couple of years. But the real thing that I think companies will benefit from is sometimes those closest to the problem have the best visibility and insights, but historically have the least voice or influence. Think about that. Visibility and insights up here and voice and influence down here. And I think we're going to see a shift, or we are seeing a shift, where that becomes much more in line and people are paying attention to those that are on the front lines who don't necessarily have the position, but do have the visibility and the ideas. So some great ideas come from other places in the organization other than the top or labs somewhere. The second big trend that I see is AI enhanced decision making. Artificial intelligence is no longer just a tech trend, it's becoming a leadership tool. And this year, expect to see more and more leaders leveraging AI for data-driven decision making. We all talk about being data-driven, and I think AI is helping us get there much faster. From optimizing operations to personalizing customer experiences. We're seeing that all over sales right now. The key is to use AI as an augmentative tool, enhancing human judgment rather than replacing it. You definitely don't want it to replace human judgment. The third big trend that I see is the emergence of the purpose-driven enterprise. And we've started to see that shift already as millennials and Gen Z begin to take on more and more leadership roles. We'll continue to see a seismic shift towards purpose-driven business models. It is a bit of a novelty today. You think about companies like Tom's Shoes, buy a pair, give a pair, Bombas, they do it with socks. And so we see that out there in the marketplace, but it's a bit of a novelty, but we'll start seeing that to become much more mainstream and part of corporate identity. And companies that prioritize social causes, giving, social responsibility, sustainability, ethical practices will not only attract top talent, but also foster deeper connections with customers who increasingly value that alignment with their personal values. They want to do companies with businesses that get them, that really fit with who they identify with as people. Like, this is something I care about. This is a company that cares about the same thing. I want to do business with them. And attracting employees is the same way because every single employee wants to be part of something bigger than themselves. There's that impact driver, and we really see that in Gen Z and millennials, which is very cool. And it really excites me personally because I absolutely believe to my core that business has a responsibility to give back and make the world a better place. And while each of these three trends stands on its own, the convergence of the trends signifies a radical change in leadership. It's not unlike the radical shift that we've seen in the SaaS world from growth at all cost to capital efficient growth. Who saw that coming? If it's grow, it doesn't matter what you spend. And now it's why are you spending money? You're supposed to be growing smart. It's just fundamentals do matter. I guess the industry caught up. But it is definitely a fundamental shift, but I think we're seeing that in other areas as well. And the shift will not just set a new standard for success, but also create a ripple effect that transforms industries, reshapes the workforce, and redefines what it means to lead in the modern era. So don't get left behind. Start adapting now and watch as your growth soars to new heights through the rest of this year and beyond. What big trends are you seeing in leadership today? Drop those in the comments. Let me know. Our founder on Tuesday was Vlad Gosman, co-founder and CEO of Involve.me. We talked about AI, no-code solutions, and leveraging past trends to create a winning company, and how a terrible product-led growth experience led me to a great experience at Involve.me. Their experience completely dialed in. Some great lessons in this episode. And our expert guest last week was Asia Arangio from Demand Maven. We talked about demand generation, where companies miss the mark in marketing, and how to identify new growth opportunities and jump on them. If you missed either of those episodes, go back and give them a listen. Today's episode is a little bit different. It gets much more technical. Some of you will love it, and others will think, hey, this is too technical. But I try and mix it up. And this one is a little deeper dive into machine learning, AI, and data science. If tech is your thing, very cool. This is for you. And if it's not your thing, cool. Go grab another episode on a topic you do love. There's a topical list on our website. So let's rock some data. My guest today is Sandy Ryza. Sandy is a lead engineer, author, and thought leader in the domain of data engineering. He is currently the lead engineer on the Dagster project, an open source data orchestration platform used in machine learning ops, data science, IoT, and analytics. Sandy co-wrote Advanced Analytics with PySpark and Advanced Analytics with Spark. He previously led machine learning and data science teams at Cloudera, Remix, Clover Health, and Keep Truckin'. Cool name. Welcome an in-demand speaker and machine learning expert, Sandy Ryza. Hey, Sandy, welcome to SaaS Fuel.
Hey, Jeff, thanks for having me on.
Tell me a little bit about your background and data orchestration and AI.
Yeah, so I am the lead engineer on the Dagster project, which is something that we're building at Dagster Labs. Dagster is a data orchestrator, which maybe I'll talk a little bit about more. But to explain myself and kind of how I got here, I can jump back maybe a decade past. My career has been this kind of loop, working on a mix of engineering projects that help people who are using data, and then working as a practicing data scientist, machine learning engineer, data engineer myself. And so I started out a long time ago at Cloudera, which is at the center of the whole big data thing, working on Hadoop and Spark, which were these software projects for helping organizations process enormous quantities of data.
Yeah.
And then got very excited about actually working on the data itself. So, we'd hear about these organizations who are our customers doing exciting things, and I wanted to be a little more on the ground with those exciting things. And so I jumped careers to initially work as a sort of data scientist consultant at Cloudera, helping Cloudera's customers do stuff with data, do machine learning, do analytics. And then jumped into a bunch of other roles, working full-time at companies, building data products. And in the course of that time, I basically came to this realization that big data wasn't the problem, or at least it wasn't the only problem. Organizations finally had the tools that they needed to process enormous amounts of data, but they were still drowning in all of the complexity of the data that they had.
Without a doubt. Yeah.
And so I was working at these companies and basically found so much of my time devoted to building internal tools that would help me and my team, the teams that I was managing, avoid this kind of drowning in complexity situation. And then I came to Dagster Labs basically because I wanted to try to build those tools for a more general audience. And so this was this loop back to working on software, in particular software that helped people like the previous version of myself who had really struggled with taming the complexity of all the data that I had to deal with.
Yeah, data is there's no shortage of data, but I think what's the real shortage is being able to turn that into actions, turn that into something that makes sense. And so, love what you're doing there. Tell me about Dagster Labs and what is a data orchestrator?
Yeah, so Dagster Labs, we build software that helps data engineers deliver data and build data platforms. So, before I jump into the nitty gritty of a data orchestrator, maybe I can talk about the broad themes of what people even use data for at companies and why they even care. I think at a high level, it's basically two things. One is making decisions. So, millions of decisions that companies have to make, decisions about what should go inside of their products, about what to prioritize. And then also people use data for products. So people will embed machine learning into their app in order to help users do particular things. People will collect data that users care about, aggregate it, put it inside their software. And so ultimately, the goal of a data orchestrator is to facilitate people doing stuff with data in that way. And so, if you think about the kind of data that's useful for making decisions, or the kind of data that's useful for including inside your product, it's often fairly clean, aggregated, joined, merged data. But the actual data that most users start with does not look anything like that. So you'll get a bunch of information from Salesforce about who your customers are, and then maybe you have some sort of logging in your application that gives you more understanding of who your users are and what kind of things that they're doing. Maybe you have some sort of partnerships or external vendors who are giving you data that is related to what your business is doing. And so you start with this kind of disorganized mosh pit of data that contains usefulness in it, but is not yet ready to be used to make decisions or power your product. And so data pipelines are these things that allow you to start from that disorganized, raw, unclean data and then develop it. So derive downstream data from it that's more useful, for these different applications. And data orchestrators are basically responsible for running data pipelines. So they understand all of the steps, all of the different intermediate data sets in that data transformation process that get you from that initial data to the final data that's useful. And they help you actually keep that data up to date and run those steps over time.
Oh, that's fantastic. And so how did you end up at Dagster? What was the driver behind that?
So I had met Nick. Nick was the founder and now CTO of Dagster, who is also the creator of the GraphQL project, which is a really important piece of software in the world of web engineering. And I had met Nick through the world of San Francisco, and chatted with him in early conversation just about our shared interest in this idea of software-defined data. And so what I mean by software-defined data is this idea. So at the time of Dagster's inception, there are orchestrators already that sort of tried to help users with data pipelines. An example would be Airflow, which is probably the most commonly used ones. But they're centered on these very task-based abstractions. So it's all about do this, then do that. and building workflows in that way. Whereas in my roles working with data and as a data engineer, I had found that actually thinking about the data in the first place was the most productive way to think about data pipelines. So if my goal was to produce data that would be useful for my app, the first thing I would do is say, okay, what is the data set that I need to produce? What is the data that needs to go into that? What's the intermediate data I need to get there? And just build out this whole network of data sets that would take me to where I was trying to go. And basically talked with Nick and really vibed on this shared idea of doing that. And so I had been building tools, as I mentioned earlier, internally inside other startups, basically to be able to think about data pipeline orchestration in this way. And Nick got me really excited about the idea of being able to build an open source version of that anybody who's working with data, anyone who's building data pipelines in the world could use. And so I jumped over and got excited about working on that.
That's awesome. Yeah, I love the concept. It's just absolutely brilliant. What are some real world examples? Let's bring it down to, what are companies using data for, and how does data orchestration help them streamline their workflows?
Yeah, so there's companies use data for so many things. I think when I'm writing out examples to write blog posts on or anything like that, often I'll start with just, everyone has a website and everyone needs to understand what their users are doing on their website. So one of the most common kinds of data pipelines is just taking all the events that happen on your website, everyone clicking on something, and then using that to try to, make some sort of decision or build some product. One of the most common kinds of ways that people build data-informed products are recommendation engines. So, very classic use case would be, users are clicking around your website, clicking on items and expressing their intent, maybe to watch a video or to purchase a product. And so a recommendation engine is basically tasked with taking all that data, that all that interest that people expect, and then using that to help them find the other products that maybe they haven't clicked on, but they'd be interested in understanding more.
That makes sense.
Website data to recommendation engine is a classic data to data informed product pipeline.
Yeah. So how has AI and machine learning affected data pipelines and the way that we use data? How have you seen that?
Yeah. So first of all, my introduction to building data pipelines is actually through a machine learning AI context. I think a lot of the way that people have come to data pipelines, especially in this age of the early 2010s when the term data scientist was really hot and exciting, is they would join an organization. It would be their job to build a model that would detect fraud or whatever their job was, and then realize that they just didn't have the data for that model.
Yeah.
So a lot of data scientists and machine learning people became data engineers out of necessity. One of the things that I often say and have very much found to be true in my own career has been that the best thing you can do to improve the performance of your machine learning model is to get better data for that model. And so what that means is that so much of doing machine learning is really just data engineering. And we think of them as basically like a continuum. So a table or a data set, that's one kind of data asset, but a machine learning model might be another kind of data asset. And ultimately the goal of your data pipeline and the goal of your data platform is to be able to produce these data assets like machine learning models or like tables, to power your product or help you make decisions in a reliable way.
Yeah, makes sense. Well, what are some of the unique features or capabilities of Dagster that set it apart from other platforms?
Yeah, so I alluded to this a little bit, but I can go into it. I think there's two areas that we think are really core to what Dagster is, that similar software out there had not prioritized in the same way that I think we have. The first one is what I talked about earlier, is this very strong data orientation. And so we call it asset-centric orchestration sometimes. The idea is that the first thing that you think about when you're trying to build a data pipeline is the data itself. You start by identifying the input data sources, the output data that you're trying to produce, and then the intermediate data sets that come along the way. So it's often the case that maybe you have some very specific data application in mind. Like you're trying to make a very particular decision about, okay, should we increase the number of sales representatives that we have in this particular region of the country? But it's often the case that to get the data that you need to make that decision, you have to build more general intermediate data assets. So like instead of just focusing on that particular region, you might actually find it useful to create a table that tells you about the performance or the productivity of all your sales representatives across all regions in the world. And so when I talk about an intermediate data asset, it would be something like that, something that would capture this more general representation of reality that you can then use to answer a bunch of more specific questions. Dagster thinks very heavily in terms of data assets, both the source data and the final data, and then also these intermediate data assets that can be useful for a bunch of different things. And I think the kind of implications of that are fairly profound when you think about orchestration and larger data platforms. If you're kind of purely thinking about tasks in orchestration, like a lot of other orchestrators do, the orchestrator ends up in this very narrow role of just executing stuff. When this is done, then execute that. But if you're able to think about orchestration in terms of assets, you become involved in you're able to help out with a lot of the larger goals that data engineers have. So for example, they want to make sure that their data is up to date and trustworthy and reliable and high quality. They want to expose their data in ways that people inside their organization can understand, so that every time someone has a question about like what data asset or what table they should use to uncover a particular fact, they don't have to necessarily ask the data engineer for every detail over time. They can go to some sort of catalog and understand that data that was produced. So Dagster's asset-centric orientation allows it to help out with this much broader set of tasks that data engineers are interested in doing.
Yeah.
So that's one thing. I know a little long-winded, but I'll jump into that one, maybe try to keep it a little bit briefer, which
Sure.
is that Dagster is really built for taking what we call it like an engineering mindset towards working with data.
Okay.
We talk about an engineering mindset. What that means is there are certain working with data is complicated, very complex. Software is complicated and very complex. And there's a set of practices and techniques that software engineers have developed over the years for managing that sprawling complexity. So for example, they find ways to test their software before it goes out to their users in order to make sure that it's high quality. They use systems like version control to make sure that they can revert back to earlier software at certain times, and they can make sure changes are reviewed, understand the history of what's going on. And so Dagster is really built for people who are thinking about data engineering inside that same paradigm, thinking about how they can test their data before deploying it to production and affecting decisions, thinking about how they can version control and manage the complexity of the software that generates their data.
Yeah. Really good use cases.
Yeah, those are the two big things: asset-centric orientation and data engineering is software engineering.
I like that. And the intermediate stages, that's really interesting and not something I'd really thought about, because normally I think about data and it's like, here's what I want to know and here's what we have to start with, but not thinking about the interim steps that you may need to do to get there. But I would think that in those interim steps, there's probably some really good outcomes that you can use for decisions and things maybe you hadn't even thought about in that process. Is that true?
Yeah, it's exactly right. And I think people find that when they're able to produce these intermediate data sets that are general and not just answering a specific question, it makes a whole set of other questions easier to answer in a way that actually encourages people to ask those questions when they otherwise might have thought it was too difficult to think in those terms.
Yeah. Or just spur some new ideas of, hey, I hadn't thought to ask this, but the data is right here. And, we just learned something and, it was a question that we didn't think to ask.
That's right. And I think one thing that we've seen is anytime that you're able to tame complexity or like make something easier, reduce the mental load of doing some task, it makes it a lot easier for other people to just like jump off of that and be more productive and move at a higher speed overall.
Without a doubt. Yeah, that's very good. Well, what do you envision the future data pipelines, data orchestration as we continue to move further into AI and machine learning? What trends or advancements are you seeing?
Yeah, so I think you mentioned AI, and that's of course a big one. The rise
Sure.
of generative AI and large language models creates this whole new world of data and this whole new world of data pipelines. I think for a long time, relational data has dominated the world of useful data. So people have been collecting kind of unstructured data for a very long time. But if you look at the kind of most load-bearing applications of data in most businesses, it's still structured data, like data that you can fit into a relational model, have in a neat
Right.
little table with rows and columns. And I think now that, AI has been going on for a long time. People have been doing computer vision and natural language for a long time, but it feels like we've really hit this, massive inflection point in terms of those applications actually being useful. And that obviously is going to have this huge impact on the kind of data, on data engineering, because it means that unstructured data like text, video, images, becomes a lot more important to what a business is actually doing. And so I think systems that can handle those kinds of unstructured data, and then I think that there's specific versions of that as a lot of software that's very targeted at training and doing inference with large language models. But I think systems that can handle unstructured data are going to become a lot more important.
Yeah. I think that's definitely a huge development and something that didn't exist. I like what you said about just the way that we've stored data, and it's absolutely true. It's been very structured in relational models, and because that was the way. We really didn't have a good way to deal with unstructured data, and now we do. And as we're looking at that, I think there's some great benefits. But before you talked about data accuracy and just validation. You want to stay on top of the latest trends? Grab my book, Small Fish, Big Pond, Building a World-Class Business That Swims Circles Around Competitors. Small Fish, Big Pond delivers powerful marketing and leadership lessons guaranteed to enhance your marketing message, wrap value around your clients, and guide their buying journey to conclude that your company is the only solution for them. It includes step-by-step frameworks and time-tested growth principles to attract ideal clients, convert them, and then transform them into your brand ambassadors. Pick up the print, ebook, or audio today at smallfishbigpond.com, Amazon, or your favorite book source. And all book profits go to charity. There you go. Using business to give back. Absolutely love doing that. How does somebody know if they're looking at a bunch of unstructured data? How do they separate the signal from the noise to know that they've got good data that they're making a decision on?
That's right. Yeah. So I think data reliability, data quality, data trustworthiness are huge gaps in the way most people work with data right now. Even when you're dealing with relational data, I think very few data engineers that I talk to actually have a ton of confidence that the data that's produced by their pipeline is consistently high quality,
Yeah.
fresh, etc. And as you were alluding to, I think that compounds even more when you're talking about unstructured data, because you don't even
Sure.
have that like basic table shape to that you can assume that your data is inside. But I think in both cases, so there's this huge broad movement towards fixing this problem. A lot of people think about it in different ways. There's the whole world of data contracts, which is asking people who produce data to set expectations about what that data is going to look like, and then enforce those expectations before they ship it out. There's a whole world of data monitoring and issue detection. There's a lot of software out there that helps you, after you produce data, make sure that data looks what like you've expected to, and apply quality checks, apply freshness checks. So I think there's this very broad acknowledgement that this is a problem, though I think it's still unclear exactly what the solution that's most like widely used is going to look like. We of course have our own take on this at Dagster. As I talked about before, one of the things about having a orchestrator that is asset oriented is that it can it can treat data reliability and data quality as a first class citizen, and do things like stop the pipeline if it encounters bad data, for example, or help people understand holistically the health of their data. So both like, oh, did your pipeline fail, or did it succeed, but the data produced by it looks bad? Like having those in a single place, I think is really important to the day-to-day activities of most data engineers. So yeah, I think data reliability is a huge focus for us in the near term.
Yeah, you can't make decisions if you don't have confidence in the data. And I think it's one of the things that happens a lot today is, an organization may say we're data driven, but then if you really look into the way they make decisions, is there may be some data and sometimes they pay attention, but a lot of times it's, I don't know about that. I'm just going to go with my gut.
Right, and many times that's because they've been burned before. They've tried to make a
Yeah.
decision based on data, and then they've later found out they made the decision and the data was wrong, or it just looks weird and it doesn't seem like they can trust it. Doesn't smell right.
Yeah.
So obviously there's this whole movement towards being more data driven and expecting leaders to care more about the data when they're making decisions, but you can't really expect them to do that if the data that you're providing them is not trustworthy or reliable.
Sure. Well, what are some best practices or strategies for successfully implementing data orchestration, data pipelines in an organization?
Yeah, so there's a lot of different dimensions to think about there. I can cover a few that come to mind. So we often talk about the concept of a data platform. And a data platform is ultimately the the place that you put your data and transform your data, expose your data, and to the various stakeholders who need access to it. There's a couple of kind of like beliefs that working with data over time has led me to believe about data platforms, and that I think are shared by the Dagster team as a whole. One of them is that every organization should try to have a single data platform. And so, if you're a organization of one, you're starting out, like your data no matter what you're doing, you have some data platform. Maybe that data platform is just like a couple Excel or like, Google Sheets in your Google Drive. That's a data platform. And, for some scales, that's, the ideal data platform. But as organizations scale, their data platform ends up needing to be a little more sophisticated, use different kinds of software. But there's a lot of power as it scales and as different parts of an organization become more fragmented, still working really hard to have a single data platform. Okay, why do you want a single data platform? It lets people work off of a unified set of facts is a big part of it. So
Yeah.
you have a sales team, a finance team, an engineering team. If they all have their own data platform with their own table or their own data sets that give their version of the truth, it's going to be really hard to reconcile that version of the truth when they have to make decisions that sort of span those different functions. Another one is it just allows machine learning people and data engineers to be more productive. So if all the data is in a single data platform, they can get access to it without having to do some crazy internal integration process. It's just there. And of course, there's like issues with governance and privacy control, but that can all happen inside of the data platform. There shouldn't be like additional technical obstacles to getting data on top of those. And then last of all, it gives the people who are responsible for maintaining the data platform a lot more leverage, in the sense that if they make some sort of improvement, if they start collecting a new kind of useful metadata or are able to handle data governance in a more sophisticated way, the entire organization is able to benefit from that kind of improvement. So that would be my number one prescription, probably, or at least up there in terms of thinking about data pipelines within your organization, is always be thinking about how you can like decrease siloing and increase order within your data platform. That's one of them. I can go into a few more, but I don't want to get too hung up on this particular issue.
How do you deal with data silos? And what's the solution?
Yeah, how do you do it? Okay, so one thing I'll say is naturally you can't expect everyone to work with data using the same technologies. So relational, data sets are going to demand certain technologies. Unstructured data is going to demand different technologies. You can't go and, if you acquire a company and want to incorporate them into your larger data platform, you can't expect them to rewrite every single data pipeline they have. And, they were using Spark and now it has to be in SQL, or they're using SQL and now it has to be Spark. So I think there's a natural heterogeneity that is inherent in data platforms. But I think the way to avoid that heterogeneity becoming a silo is to try to have some sort of common fairly flexible layer on top that's able to understand that all the different technologies are able to fit into. So like not everything has to be stored in Snowflake, but if you can draw this single dependency graph of, okay, here's this data set that's in Snowflake and it came from this data set that was in this other storage system, and then it's used to create this machine learning model, that still gives you the ability to standardize and align on some broad shared language for talking about the data that you have and giving people access to data that aren't necessarily part of the organization that's responsible for producing.
Like that. Well, what other strategies or best practices? You said you had several and we got one. What are some others?
Yeah. Love talking about this stuff. The other one, I talked about this a little bit earlier, is to, data is generated by code. And so that means data engineering is software engineering. And so, I think what that comes down to on the ground is there's lots of simple tools out there that will allow you to do fairly basic things with data just through a web interface. And those tools have their place. So for example, for people doing business intelligence, often it's useful to be able to click around and make a chart. But when you think about the code that actually is responsible for managing kind of the tangled web of data, or if you think about the process of managing the tangled web of data inside of a data platform, I believe that largely needs to be managed through code and not through a pure web UI software. I touched on this a little bit earlier, but ultimately, code is the best way that we have of managing enormous amounts of complexity. Version control, review, testing, and then working in a sort of straightforward but Turing complete language like Python allows you to handle the whole gamut of crazy things that people want to do with data. And so, we strongly recommend if you're going to work with data through a UI, do that a little bit more at the edges, and then trust code and more standard software engineering processes for handling data pipelines and doing the complex data transformation that kind of powers the engine of your data infrastructure.
Yeah, that makes sense. Using the code on the inside and think manual more on the outside. Yeah, that makes sense. A lot of talk and a lot of growth. AI, machine learning technologies that continue to advance, a lot of automation, and even talking about working with code with the data. How do you see the role of human intervention fitting in that?
Yeah, so I guess there's a bunch of different pieces to think about there. So one kind of dimension of this is labeling. If you look at what makes our present day AI systems so powerful, a lot of it boils down to the immense amount of work that humans have put in to helping to guide their outputs, right? So
Sure.
OpenAI had GPT-3 for a while. It was maybe fundamentally this amazing piece of technology, but it wasn't really useful until ChatGPT. And the big innovation of ChatGPT was basically getting a bunch of humans to do basically manual reinforcement learning, look at the outputs of GPT-3 and say which ones were good and which ones were bad. And I think GPT kind of went from being a toy to being this very cool and amazing and useful product because there was that human labeling process. I think a separate tangent to this is just in the world of data engineering and data pipelines. In an ideal world, you set up your data pipeline and execute every day. You never have to touch it, and you have some sort of schedule or some sort of triggering process that is automatically executing it. But in reality, so much of data engineering is the edge cases and working around these situations where doing that automatic, updating your data doesn't make sense. So, in the world of data engineering, backfills are probably the place where this comes up the most. So for example, you have some data set that is maybe being updated incrementally and everything looks good. Then you understand there's something that requires some manual intervention. So maybe you notice a bug in the logic that generates the data set and you realize that, for some column, it's been computed incorrectly for the past 2 years.
That happens.
It happens. It happens quite frequently. you add a column and you want to backfill that column for the past few years. And so those are the situations where humans really need to be actively involved in reconciling things.
I like that, the human connection into that, really helping to drive AI, and they feed off of each other. So either one alone is not nearly as powerful as the combination of the two together. So
That's
there's
right.
certainly a lot of benefits.
That's right.
Well, how about an example, particularly challenging data orchestration problem that you've encountered and how you solved it?
Man, okay. Let's see. I think, well, maybe let me clarify that a little bit with you. Are you thinking about a challenging data problem that gets solved with data orchestration, or like a challenging problem we've faced when designing how Dagster should work?
No, I think more of a challenging problem dealing with data that orchestration solved.
Got it. Yeah, so I used to work in a healthcare background. I was at Clover Health for a while, which is a company that they're still around. They have an approach to Medicare that I think the idea is being able to be very data focused, database, and do better risk management. Try to do better preventative care for the people that are enrolled in their plans. And healthcare data is just like the boss battle of any sort of data tool.
Yeah.
And the reason for that is just the amount of different standards, the amount of different ontologies, the amount of the different coding systems or codings for procedures, codings for conditions. Data comes from so many different source systems. So if you are a health insurance company, the data that you have is largely based on claims. So you have people who are or people or hospitals that are coming to you and saying, this healthcare happened, you need to pay for it. And through that process, you learn about the world and you learn about what healthcare is happening there. And I think the ultimate goal for an organization like Clover Health is to use that information to help provide better care for and get better care for the people enrolled in their plans.
Makes sense.
But what it means is that the kind of final thing they're trying to understand, maybe a question like, how often are people admitted to the hospital in this region or something like that, comes so many steps away from the actual input data that they're looking at. So the input data is, a claim, which is like a fax of a piece of paper that comes from some software from some hospital chain somewhere. And then the number of steps that they have to do to actually turn that into useful information is just totally mind-boggling. I think that's really what kind of turned me onto this problem that in the first place was just trying to fit all of this in my head, and with other software basically just being unable to. You have this massive tangle of code that starts with that data and produces other data. And so one of the ways that orchestration really helps with this is just allowing you to visualize it, understand that lineage of this ultimate data that I'm trying to use to make a decision, going all the way back to that fax of a healthcare claim that was produced far up. And then inevitably what will happen is that as you try to produce that clean useful data, you'll encounter problems. So you'll hit errors. You'll notice that supposedly clean useful data doesn't, there's no data there at all, or all of the numbers that are supposed to be positive numbers are negative numbers. And be able to walk back through that, we call it an asset graph in the world of Dagster, but walk back through that network of data sets and understand where things went wrong so that you can fix it.
Nice. Well, if you have an organization that is where we started at the beginning, drowning in data, and they've got a whole lot of things there and not necessarily using it, what is the place to start and to turn that mountain of data into something that is useful for decision making?
Yeah. So I think there's a few different dimensions to it. I think, first of all, the most important dimension is finding the right people to, who can deal with this data.
Sure.
That means, basically hiring a data engineer or finding someone in the organization whose title isn't going to be data engineer, but can do that process of data engineering. And one thing I'll say is that a lot of people who do data engineering aren't titled data engineers. And that's great. There's so much overlapping skill sets between all these other roles like data platform engineering, analytics engineering, and data science. So find the right person. Think about what you want your data platform to look like. What are the main technologies you want to use for storing your data and for processing your data and for orchestrating your data? And try to develop some sort of vision for, as complexity increases, how you're going to keep things under control. How are you going to get a top-down view of everything that's going on inside of your data platform and how everything relates to everything else? And then basically building inside of that framework. Like, obviously you don't want to overcomplicate it at the beginning, even though, like I talked about earlier, having lots of different technologies can be inevitable. If you can get away with just a single data warehouse and throw all your data in there and then use SQL to transform it, that's obviously going to make your life a lot easier than starting with a bunch of different technologies and coming up with a complicated plan for how all those technologies are going to interact. But even starting with that relatively simple platform, just keeping in mind that at some point you're likely going to have to bring in other technologies as well, and trying to make choices that allow you to be flexible in that way as your platform expands.
Yeah, that's really good advice. Well, where can people learn more about you and about Dagster Labs online?
Yes, you can visit us at dagster.io. You can check me out on Twitter, S_Riz, RYZ, or on LinkedIn, Sandy Ryza.
Fantastic. We'll make sure and link all of that in the show notes. Sandy, thanks for being on the show. It's really informative.
Thanks so much for having me, Jeff. Really enjoyed it.
Thanks again, Sandy, for coming on the show and sharing your insights and resources. Now, a keyword that some of you may have missed is open source. That is amazing. Fantastic tool. You can check it out at dagster.io. And of course, follow Sandy on social for more machine learning and analytics info. Great insights there. As always, all links, highlights, resources, and full show notes are available at saasfuel.com. If you got value today, please share the episode with another tech wizard. Everyone who shares this week gets a wizardly neural network, a spellbinding system that learns from your data, making predictions and uncovering insights as if by magic. Join us next Tuesday, where our founder is John Conifay, a U.S. Air Force veteran and CEO of Integrate. He has a rich background as an early employee at 3 space unicorns. And somebody tell me when I say space unicorns, if you start hearing the song play in your head. Drop that in the comments if you even know what I'm talking about. And next week on our SaaS Fuel Expert Series, we have second John. First John was John Conifay, founder. Second John, we have John Sarver, our expert. John Sarver is a Navy vet, innovation and technology consultant at SaaS Logic. We'll be talking about usage-based pricing models that work today, hybrid billing systems, and of course, pricing to win. I will see you next time, and as always, enjoy the journey.
Thanks for listening to SaaS Fuel. Full show notes for each episode, which includes a summary, key takeaways, quotes, and any resources mentioned, are available at saasfuel.com. Be sure to follow and subscribe wherever you listen to podcasts. And if you're enjoying the content and getting value from these episodes, please leave us a rating and review at ratethispodcast.com/saasfuel. We'll be sure to read these out on future episodes.